All right, ladies and gentlemen, welcome back to Honors Advanced Algebra with Mr. Gotch. Here we go. Where our goals are for today, we're going to work on applications of these rational functions. So basically solve these application problems today. There's a warm-up on top of your paper. I'll do that at the very end. That way you can just bypass and you can check it later. We're going to dive right into these work problems. Understand that when we do work problems, specifically, the idea is the rate at which somebody works at times time that they're on the job is going to get one job done. So rate times time is one job getting done. And eventually time is how much they worked to get that one job done. So if we can remember that, this is going to be super easy. So here we go. We got Peyton as a bricklayer. He can do a job in 5 days. Luke is also a bricklayer and can do the same job that Peyton did in 4 days. How long will it take them to work together? So I have two people today. I've got Peyton. If you want to make a box, you can. We got Peyton and we got Luke. All right, so how long it takes them to get the job done is, for Peyton, it took him, 5 days? And for Luke, it only takes 4 days. Well, we want to figure out what their rate is. Their rate is, what do they get done per day in this case? So in this case, Peyton's rate per day is 1/5. In 1 day, he gets 1/5 of his job done. And Luke's rate in 1 day, he gets 1/4 of his job done. And on the second day, he'll be done with half of it, and so on and so forth. Well, we're going to let T be time. Together. So T is their time, work together. So for Peyton, his rate is 1/5 times T. Lucas's rate is 1/4 times T. Because they're working together doing the same thing, they're not fighting against each other, we're going to add those together. And now we're going to set that equal to one job. And one job is just 1. So now we have our work set up. This is Peyton's work. This is Luke's work. They're working together, so addition equals 1. Well, now we want to solve something like this, and this is where, if you want to work with fractions, you can, but a lot of people don't. So the easy thing is to go ahead and multiply everything by the LCD, and hopefully we agree that the LCD is 20, 5 times 4. Well, I can even write that up here. LCD is 20. So I'm going to go ahead and multiply every term by 20. There are 3 terms. And remember, terms are separated by plus signs and equal signs. And now we do our math magic. Do. You can wave your fingers, and anything highlighted will disappear. 20 divided by 5 is now 4. 4 times 1 times t is now 4t. Do. 20 divided by 4 is now 5. 5 times 1 times t is now 5t. And last but not least, 20 times 1 is 20. Combine your like terms, we get 9t equals 20. And to figure out how much time they work together in terms of days, go ahead and take 20 divided by 9 in your calculator. And I got about 2.2 days. So again, this is the basic idea when you're doing work problems. Find their rate. Take what they're doing and divide it. Basically put a 1 over that number. And that's going to find you their rate per day or per hour or per minute. Okay. So same idea with number 2. It says 2 pipes can be used to fill a water tank. One pipe alone can fill it in 27 minutes. The second pipe can fill it in 54. A third pipe, the drain pipe, can empty it in 36 minutes. If all valves are open with the tank empty, how long will it take the tank to be filled? All right, so we have a few pipes here, so you don't have to set this up. It's just sometimes it's nice to have kind of an organizer. We have 3 pipes. We have pipe 1, we have pipe 2, and then they also said we have a drain pipe. All right, to fill the tank is one job. And it says the first pipe, pipe 1, can fill it in 27 minutes. Pipe 2 can do the job in 54 minutes. But the drain pipe empties in 36 minutes. So if you think about it, that's negative, right? It's taking water out. So I'm going to put a negative 36 there. Well, their rate per minute, in 1 minute, they get 1/27th of it done. In 1 minute, pipe number 2 gets 1/54th of it done. And the drain pipe, in 1 minute, gets 1/36th of it done. But remember, it's draining, so it's taking water away. So takeaway is subtraction. So we're going to use that same idea up here. Rate times time is equal to 1 job done. So I'm going to take pipe number 1 times time. Again, T is time worked together. We're going to take pipes 2, rate, times time. But now the drain pipe is working against them, times time. And now that's equal to 1 job. So these two are filling it, but this one is taking it away. So that's why we have subtraction. So now what we're going to do is going to multiply everything by the LCD. Take the first one, 54. Okay, least common denominator has got to be at least the biggest one. Does 27 go into 54? Yes, but does 36? No. So now do a multiple of 54. If I take 54 times 2, that's 108. And if you look, 108 is divisible by, again, 27 and 36. So 108 is our LCD. All right. So I'm going to multiply everything by 108. Every term, even the 1. This is the one that people forget. You don't just do it to the fractions, you got to do it to this term also. The idea is if you do it to one side, you got to do it to the other side. And then we have to distribute it to all the sides. So we throw this in the calc. We take 108 and divide by 27. That's 4. Times 1t is 4t. 108 divided by 54 is 2. And 2 times 1 times t is now 2t. 108 divided by 36 divides nicely, and that gives you 3. But 3 times negative 1t is now negative 3t equals 108. So on this side, you should always get your LCD. Over here, we got 20, right? In the previous problem. Well, combine your like terms. 6t minus 3t is now 3t. Go ahead and divide by 3. And the time that it takes working together was 36 minutes. 108 divided by 3. Okay, again, these are word problems. You should have some kind of units. What are we talking about? What's our time? Okay. So those are 2 examples of work problems. If things are working together, we're using addition. If things are working against something, then we use subtraction. So now the last one we talk about here, example number 3, and I'll do extra examples if you want to follow along. Here is your basic distance equals rate times time problem. So distance is rate times time. Now you can manipulate that formula so that you can solve for different ones. If you want to solve for r, divide over the t. So you would get r by itself, and now you have d over t. You can also get the t by itself by dividing over the r, so you can get t is equal to d over r. So again, any of those three you might use. You just got to see what they're saying. Okay. And again, in terms of making tables, it's kind of helpful. So here we go. It says a car travels 300 kilometers in the same time as a train travels 200 kilometers. The car's speed is 29 kilometers per hour, more than the train's speed. Find the speed of both. Okay, so we're trying to find their rate, their speed. So we're going to make R is the speed, the rate. And we'll distinguish which one is it. Is it the cars or the train when we set up our little table here. So here we go. I'm going to make a little table just to help organize. I've got the car. I guess we don't need number one. And we got the train. If we have multiple cars, we do car one, car two. We just have two vehicles, car and train. We have their distances. We have their rates. And we have their times. So it's here, car travels 300 kilometers, so that's 300. In the same time as train travels 200 kilometers, so that's 200. The only thing I know about the time is they're the same. And we'll come back to that. Rates, this says the car speed is 20 kilometers an hour more than the train speed. Well, I don't know what the train speed is, so I'm going to make that R. And now R is the speed of the train. Well, this one is 29 kilometers more, so I'm going to take the train speed and add 29 to it. Last but not least, again, the time, only thing we know is that they're the same. So if you think about it, the time for the car is the same for the time for the train. That's what they're saying. Well, now, if I know T equals T, that's where I use this one here. Because I got information about D and R. All right, so if I look at my car here, I know distance is 300, and I know my rate is R plus 29. And if I look at the train, D over R for time, the distance is 200, and my rate is R. So now we have a proportion, and you can solve this a couple different ways. If you want to multiply everything by the LCD, you can, or a lot of us learn just cross multiply. So we can go ahead and do that. I get 300R. And go ahead and cross multiply here. We're going to distribute 200 times R. That's 200R on this side. And 200 times 29 is what, 5,800? And now this is where we want to solve for R for the train. Go and subtract over. We get 100R equals 5,800. Now we can divide by 100. Just cancel out those zeros. And we get R is 58 kilometers an hour. And again, that's for the train. Now, quiz or test, if that's your answer, you're going to lose a point because it says find the speed of both. So I've got the train, but you've got to make sure that you get the car as well. So go ahead and plug it in. Go ahead and plug in 58. So over here for the car, I've got 58 plus 29, and we get 87 kilometers an hour for the car. So quiz or test, make sure you answer both questions. Okay, my math lab, you got to make sure you put in the correct one. If they're only asking for one, if they ask for both, make sure you put in both. All right, we got one last question, and then everything else is just extra. If you want to see those, we can show you those. So here we go, ladies and gentlemen. The last one is some numbers. So here I've got the ratio of 5 less than a number. and 3 more than a number is 1 to 2. What is the number? So as I set this up, first off, we got to identify our variable, and it says I have a number. So you can have that anything you want. If you want to make it x or whatever, if I'm just going to do n for the number. So it says the ratio means fraction, the ratio of 5 less than a number, that means I'm taking away 5 from n. Well, I would write that as n minus 5. And 3 more than a number, well, I would be adding 3 to n. So 5 less than, again, that's always written backwards, you like flip-flop the idea. So you're taking 5 away from n, and then 3 more would be n plus 3. Is equals 1 to 2. That's just a 1 to 2 ratio. And then from there, just cross multiply, make it easy. Cross multiply. We got n minus 2 times 2, or excuse me, n minus 5 times 2 is 2n. 2 times negative 5 is now negative 10. And 1 times n plus 3 is just n plus 3. And we can go ahead and solve. Subtract the n over. That's n. I'm going to add the 10 in the same step. We get 13. Now double check that that isn't an excluded value in this case. Again, n couldn't be negative 3 in terms of domain. That's not an issue for this one, but just be aware that it could be an issue. Ladies and gentlemen, that is it for today. If you want to see more, I will continue on so that you can see a few more problems. But I'm not going to set up the boxes and stuff, just make it really easy. Again, when I do these problems, this is how I'll do them, on my own. I won't set up boxes and all that stuff, but you can always use them to organize your data. So here we go. Example number 5 says Ethan can wash and wax a car in 4.5 hours. Carter can do the same job in 3 hours. How long will it take both boys working together to wash and wax the car? So again, we're going to let T be time work together. And Ethan is 4.5 hours. I'm going to go just 1 over 4.5. And then Carter does the same job in 3 hours, so his rate is 1/3. Well, if I take rate times time, rate times time, that gets 1 job done. Because they're working together, it's going to be a plus. All right, so as I take a look, I want to get rid of these denominators. Again, if you wanted to make 1 over 4.5, simplify that, you can. It doesn't really matter. LCD, if I throw in the calculator, if I take 4.5 times 3, I get 13.5. So I'm going to multiply everything by 13.5. And now these cancel. 13.5 divided by 4.5 is 3. So I get 3t. 13.5 divided by 3 is just 4.5. 4.5 times c is 4.5. And 1 times 13.5 is that LCD. Just combine your like terms. Don't forget the t. Go ahead and divide. And in my calculator, when I take 13.5 divided by 7.5, I got about 1.8 hours. So about 1.8 hours together, just less than 2. All right, let's look at number 16. It says the tank can be filled by a hose in 15 hours. It can be emptied by a drainage pipe in 25 hours. If the drainage pipe is open while the tank is being filled, how long does it take to fill the tank? Oh man, what a waste of water. So here we go. Rate times time. 15 hours, so in 1 hour, 1/15 is done, times time. Again, T is time worked. The drainage pipe is 25 hours, so in 1 hour, it drains 1/25 of the tank. Because they're working against each other, this is draining, this is filling, the drain pipe is negative. And eventually we will get one thing done, one tank filled. So go ahead and look at your LCD. I've got 15 and 25. So start at 25, that's not divisible by 15, then do multiples. 50 is not divisible by 15. Ooh, 75. 75 is, so my LCD is 75. So I got multiples of 75 here. If I take 75 and divide by 15, if you want me to highlight those denominators, I can. Math magic. 75 divided by 15 is 5. And 5 times 1 times t is 5t. That gives me 75 divided by 25 is 3. Negative 1t times 3 is negative 3t. And now that equals 1 times 75, which is that LCD. All right, add your like terms. That's 2t equals 75. And solve for t. Divide by 2. 75 divided by 2 is 37 and a half hours. A lot of wasted water. Make sure those drain pipes are closed. All right, ladies and gentlemen, last one. We got distance equals rate times time. Just uniform motion. Here we've got a plane that flies point A to point B is 50 miles an hour. With a 50 mile an hour tailwind is 3 1/3 hours. Returning against the same wind, it takes 4 hours. What is the speed of the plane if there is no wind? So speed, I usually just make it R. Speed of plane. And I'll write this one out. The plane is going there, going from A to B, and then back. And I'll do distance, rate, and time. All right, so a plane flies from A to B and then returns from B to A. So their distances are the same. The rate, when I go there, he's got a 50 mile an hour tailwind, which means it's pushing, it's making them go faster. So it's the rate of the plane plus the tailwind, it's helping. But on the way back, it's going against that same wind. So that's R minus 50. Because they're fighting the wind. It's making it go slower. Time we have is 3 1/3. 3 1/3 looks like that. And you might want to get as a mixed number. It might help you. I don't love mixed numbers. I like impropers. So you might want to go 3 times 3 is 9, plus 1 is 10/3. So you might want to do that. And then on the way home it takes longer because they're fighting the wind. That's 4. Well, because distance is the same, this is where the distance there is equal to the distance back. Okay, so I'll do this one in red here, fuchsia here. Distance, remember, is rate times time. So I'm going to take my rate, which is R plus 50, and multiply by time, which is 10/3. All right. And over here, I'm going to do my rate, which is R minus 50, and then times 4. Now, again, I don't know about you, but I don't like working with fractions. So an easy thing you can do is just multiply by the LCD. In this case, the LCD, there is only one denominator, which is 3. So if I multiply by 3, I got to do it to both sides. And I wave my fingers. Doo-dee-doo-dee-doo. And these 3's cancel. And now I get 10 times this quantity. I can go ahead and distribute. That's 10R plus 500. Nothing cancels over here. 4 times 3 is 12. And now I would distribute. That gives me 12R. And 12 times negative 50 gives me negative 600. This is where I would get my R's on the same side. That's 2R. And then I would move this guy over, add 600. That gives me 1100. Go ahead and divide by 2. And my rate for this plane is 550 miles per hour. Ladies and gentlemen, that is it for the lesson. I will post up the answer key so you can see the warm-up. And that is it. You guys have a great day.